Hi, my name's Steve Mann and this is Paper Classroom. Welcome to another one of our science modules. In this module we're going to be talking about covalent bonding. Now there are four types of bonding. Ionic, covalent and hydrogen bonding are all relevant to the paper industry, so we'll be discussing all of them. Metallic bonding, not so relevant, so we're not going to bother about that, but at least you know that it exists should you wish to find out yourself. Now this is a picture of the top part of the periodic table, and one of the interesting things is in groups 1, 2 and 3, this one and this one, any element in that group is happy to give away its outer electrons. So anything in group 1 will give out 1 electron, anything in group 2 is happy to give out 2 electrons, and anything in group 3 is happy to give out 3 electrons. Over at the other side of the table, what I used to call group 7A in the olden days, now group 17, anything in here is happy to accept 1 electron. Anything in this group, 6A as I used to call it, 16 these days, anything there is quite happy to accept 2 electrons. And anything in this group here, group 3A or group 15, everything there is quite happy to accept 3 electrons. That leaves this group here in the middle, group 4. Group 4 needs to either, in order to get to the 8 electrons it either needs to give away 4 electrons or it needs to acquire 4 electrons. And both of those processes are far too difficult. So what elements here do instead, they have a different technique, not giving away or accepting electrons, but sharing electrons. So the clue to sharing is in the name of the type of bonding, covalent, as in cooperative. So if you're cooperating, you need more than one person to cooperate with. So covalent bonding is all about elements or atoms cooperating. And what we're going to use as our example is methane. This is a classic example of covalent bonding, and it's one of the simplest. So methane consists of 2 elements, carbon and hydrogen. Here we have a hydrogen atom. What do we know about hydrogen? Its atomic number is 1. Because its atomic number is 1, that means that we know it has 1 proton. And in order to be electrically neutral, if it has 1 proton, it must have 1 electron. So there's our 1 electron. Now, the K shell is only really happy, only fully satisfied if it has 2 electrons in its shell, in its orbital. So ideally, it would like this second electron, but it doesn't have 1 unless it acquires it from somewhere else. If we look at carbon now, carbon, nomenclature C, the atomic number of carbon is 6. That means it has 6 protons, and in order to be electrically neutral, it must have 6 electrons. So let's have a see how the electrons are. In the K shell, 2 electrons. So the K shell, the innermost shell, first shell, is now completely full. It cannot hold any more electrons. So the remaining 4 we must start to place in the second shell. So there's our 4 electrons in the second shell. So again, carbon has 4 electrons. It would love to have 8 electrons. So the question is, where can it get these 8 electrons from? Remember, it can't accept them. It can't give away those 4 that are already there to leave just this inner shell. So it must do something else. It must share electrons. Now, here we have the system that we're going to work with. This is the carbon atom with its 4 outer electrons. Here we have 4 hydrogen atoms, each with their own 1 electron. And what happens now is that these things come together. And now if you look what's happened, this hydrogen atom is sharing its electron in the carbon orbital here. Similar for here, and for here, and for here. So carbon now has the 8 electrons that it needs. But hydrogen doesn't have any at that point. If you look now, this hydrogen's electron goes around there, the hydrogen's electron goes around there, around there, around there, and then the electrons from the carbon all move over. And so now you can see that each hydrogen has the 2 electrons that it needs, but carbon only has 4. Next it will switch over again, the electrons will move again, carbon will have 8, hydrogen will have none, then they'll switch again, and you'll have this situation all over again. So the carbon, or the electrons from the carbon and the electrons from the hydrogen, which by the way are completely undistinguishable, will take turns at travelling either round the hydrogen or around the carbon. So one moment the hydrogen is fully satisfied, the next moment the carbon is fully satisfied. So covalents share. Back again. Thank you very much for watching this video on covalent bonding. I hope you enjoyed it. Please watch our other videos and please leave us feedback.